Okay, so these are really, really important sections, these 3-5, this 3-5 and 3-6. In fact, math is really all about the study of relations and functions more than anything else. Okay, so let's take a look. The idea of a function, it's a relation. So all a relation is just a pairing of items from one set to another set. So what a function does is it pairs them off in a special way. Okay, it pairs them off so that from the first set, it's only paired off with one thing in the second set. So if something's from the first set, it can only have one pair off from the second set. Okay? So a function is a relation that pairs each item from the first set, called the domain. So the first set is called the domain, to the second set, called the range, in the following way. Each domain value is only paired with a single range value. Okay? So for example, we can look at functions as an arrow diagram. So our domain is 1, 2, 3, 4, and our range is 5, 6, 7, 8. So 1 gets only paired off with 6. If we look at the pairing here, 1 gets paired off with 6. 2 only gets paired off with 5. 3 only gets paired off with 7, and 4 only gets paired off with 8. Since each domain value has one pair in range, it's a function. So let's look at a second scenario. Our domain is ABC. Our range is XYZ. So A only gets paired off with X. B, starting at the first set, how many pairs does it have in the second set? Only gets paired off with X. And C only gets paired off with Z. Since A only has one pairing over here in range, B only has one pairing in range. It happens to be the same pairing as A, but that doesn't matter. And C only has one pairing in range. It's a function. So if we look at this one, our domain is X, Y, and Z. Our range this time is ABC. X gets paired off with A and with C. Since X has two pairings, it cannot be a function. It cannot be a function. Sometimes we see functions as sets of ordered pairs. Sets of ordered pairs, remember, are in XY form. X is always a domain value and Y is always the range value. So when we start to look at a set of ordered pairs, we look at X. Okay, what are the X values paired up with? How many pairings do they have? So if I look at this, I have an X value of 1. It gets paired off with only one item, 2. The second ordered pair, I have an X value of 2. That's not the same as this, because this time we're starting at 2. That only gets paired off with 1. So, good so far. 3, an X value of 3, only has one Y value of 5. Good. 6 only has one Y value of 7. So, that's a function. Conversely, in this one, 1 gets paired off with 2, 3 with 8, 7 with 9, whoops, and then 3 again, but this time it gets paired off with 2. Since it pairs off with 8 and 2, it's not a function. It's a relation, but not a function. Any questions about that? As a graph, we use the vertical line test to determine if the graph is a function. Okay. If a vertical line passes the graph only once, everywhere, it's a function. If there's at least one vertical line that passes more than once, it's a relation, but not a function. So this first one is kind of this S curve or Z curve, if you will. That vertical line crosses the graph 3 times, so that cannot be a function. This other one, we kind of have a smiley face. Every vertical line is only going to cross once. Vertical lines, remember, up and down. So that's a function. We can also write functions as equations. And this scenario, sometimes it's called functional notation, this F with the parentheses and then X. This is pronounced f of X, or a function of X. F of X and Y can be used interchangeably. So f of X is Y, but it's just another way to write it. And it tells everybody, instead of just an ordinary Y, this particular Y is equal to a function. Okay? And this also gives us a better evaluation tool. So let's suppose f of X equals 3x minus 8. And we're asked to find f of 2, f of 0, and f of minus 2. So what f of 2 means is any place you see x in this original equation, we replace that x with a 2. So I substitute 2 in for x and then evaluate. So 3 times 2 gives us 6, minus 8 gives us negative 2. The f of 0, this middle one, means every place we see x in this original equation, we're going to put 0 in. So instead of 3x, we have 3 times 0, minus 8, which gives us minus 8. And similarly, when we see f of minus 2, that means in the original equation, we replace the x with minus 2. 3 times minus 2 is minus 6, minus 8, that gives us minus 14. A word of caution, whenever you substitute in, make sure you put parentheses around things. It's helpful, and you're less apt to make errors. Let's look at another one. Suppose we have g of x equals 2 times the absolute value of x minus 3 plus 8. So we substitute minus 6 in for x in the original equation. So that's going to be 2 times the absolute value of minus 6 minus 3 plus 8. Now we're going to use what's inside the absolute value first. Minus 6 minus 3 gives us minus 9. 2 times the absolute value of minus 9 is 2 times 9. So that gives us 2 times 9, or 18, plus the 8 gives us 26. Any questions about that? And then we can do combinations like h of t equals minus 2t minus 1. Find h of 1 plus h of 3. So that means we're going to find h of 1 and we're going to find h of 3 more or less separately. So in h of 1, in this original equation, every place I see a t, I overwrite it with a 1. So this part right here is the h of 1. H of 3 means every place I see a t in this original equation, I put a 3 in. So this part right here is the h of 3. So now I'm just going to follow the order of operations. Minus 2 times 1 is the minus 2, minus 1. Plus 2 times 3, well, that's going to be 6, minus 1. Going left to right, minus 2 minus 1 gives us minus 3. Minus 3 plus 6 is 3, minus 1 is 2. And then we have f of x equals minus x plus 1 over minus 2x minus 3. And this one says, find f of x plus f of minus 1. So now, be careful. When it's f of x, you just write f of x. So I'm just going to rewrite this. And I have it rewritten right there. Plus then, f of minus 1. So I'm going to put a minus 1 in every place I see x here. And again, make sure to use those parentheses when we do our substitution. So that's going to be minus x. So it'll be a minus minus 1, which is the same thing as a plus 1. Okay. And then minus 2 times minus 1 is going to be a positive 2. So we have 1 plus 1 in the top, which gives us 2, over 2 minus 1 in the bottom, which gives us minus 1. So this part is going to be 2 over minus 1. This part doesn't change because it's already f of x. So our final answer looks like that. There's the f of x part. And then this part, that 2 over minus 1, that translates into minus 2. Any questions about that? Then we have one last problem. This one says a of x equals 3 times the absolute value of 2x plus 1. Find a of x plus 1, then simplify. So a of x plus 1 means we substitute x plus 1 in for x. So every place I see an x here, right by this 2 is the only place, I'm going to substitute in x plus 1. I'm going to make sure x plus 1 is in parentheses because every time I substitute, I make sure things are in parentheses. So that gives us 3 and an absolute value of 2. And then instead of x, now x plus 1 in parentheses plus 1. I'll distribute the 2, giving us 2x plus 2. 2x plus 2 plus 1, well, that's going to be 2x plus 3 in the absolute value with the 3 outside. So that's all the further we can simplify. Any questions? Yes, no, maybe?
No, just a question regarding the Newton assignments that we have to do for the week? Is it just the 3 of them we have to do?
Just the 3 of them.
Oh, okay, I just making sure because when I was
I
looking.
want to make sure you spend some time on these 2 sections in particular, and a little bit of time. The other one is pretty time consuming too, or can be. So I just gave you 3 assignments this week. Okay.
All right, awesome. Yeah, it's been a while since I've done this, so
Actually, I think I'm not sure. Is 4.1 also included in there? I don't remember. Let's check. Okay. Hang on a second. It's probably the best idea. I'm going to do a screen share here in a sec. Okay.
Okay.
I'm not leaving you. All right. Okay, let's see. Content module 2. I did want you to spend a little bit of time though on this stuff. So 3.5, 3.6, and 4.1. Okay, yep, that's what I thought. Okay. And don't worry about the systems of equations worksheet. That was a great idea, but then in practicality, I realized, let's skip it. Okay.
Okay, awesome. Thank you.
Okay, is that it?
Yep, that's all I had.
Okay, have a good day. We'll see you next time.